Hi, my name is Lauren Coe. I am a programmer at the University of North Texas Libraries. I am presenting as part of the panel on browser-based crawling for all the stories so far. I'm talking about using Browsertrix Cloud for improving the web archive experience. For some background on web archiving at UNT Libraries, we crawl the unt.edu subdomains, of which there are several dozen since 2005. We do this twice a year, and it goes into our UNT Web Archives collection. We also crawl the websites of closing federal commissions and agencies. Since 1997, we've been doing this, and those websites go into our Cyber Cemetery collection. And then we've also done some themed crawls around various events and topics. For crawling and access, we've been using Heratrix for the majority of crawling for about 15 years. We have been using OpenWayback for the majority of that time for access, though we have in the past year or so moved to putting new content into PyWB. In addition to using PyWB for access, we use it for crawling when there's content that we can't get with Heratrix, and if it's high priority enough. I'll mention that we also have an Archive-It account at UNT Libraries. It's used by our Special Collections Division, which is separate from the division that I'm in, and they use it for limited crawling of content that supports some of their existing collecting areas, such as LGBTQ studies and the university archives. That said, we do really like to use open source software in my division. So we are eager to join the project Browser-Based Crawling System for All, that is a project where IIPC is supporting Web Recorder in its development of Browsertrix Cloud. Browsertrix Cloud is software for open source browser-based automated crawling for high fidelity web archives. The IIPC members involved on this project are the Royal Danish Library, the British Library, the National Library of New Zealand, and UNT Libraries. And we're working with Web Recorder, who's doing the software development, to provide use cases, requirements, and testing of the Browsertrix Cloud software and of local deployments. The use case for UNT Libraries that I was trialing for Browsertrix Cloud is to acquire and replay websites embedded video seamlessly, crawling it with Browsertrix Cloud, and then replaying it in our locally hosted instance of PyWB. You can see it in this top screenshot that we have pages with the URL not found where you should have an embedded video, and then after crawling with Browsertrix Cloud, we've got the embedded video showing in the page. By using Browsertrix Cloud, we're improving the web archive experience for all stakeholders. It's an improvement for the practitioner, such as me, who no longer will need to use PyWayback Record mode to manually archive embedded video and other hard-to-get content. It's an improvement for our system because we can stop crawling videos with Heratrix and its extract or YouTube DL, because those videos don't automatically replay in the page, and I think they get a lot of duplicates, so it takes a lot of space. And also YouTube will often deny our requests with 429 for too many requests. It's an improvement for end users because obviously they get embedded video working in the archive, so it's more like a live page experience. And there's an improvement for site owners, like those people who come to us with federal commission websites, who used to hear things from us like, we can get your video from YouTube, but it won't replay in the archived page. And if you want it to replay in the archived page, we could add your videos to the UNT Digital Library and give you the code for embedding them on your site, so they'll replay in the archive, which we did in this site that I show here for the Women's Suffrage Centennial Commission. Before we were doing any embedded video with PyWayback Record mode, we would tell site owners that to keep a video accessible to users from the archive, they could add a direct download link for all of the embedded videos, which I do still like as an option. It's just not generally feasible for big sites or where you don't have contact with the site owner, because it does make it easier to access video no matter what the replay software is. But some some commissions or agencies didn't have somewhere to host video. So then we would tell them that if they want to provide a direct download for their video file, we could host it and then they could link to it from our server. And so here is an example of a site that did that, where we were hosting their video files, they linked to it for download from their site, and then we crawled them for our archive. But to avoid all of that and improve the web archive experience for everyone, we set about deploying BrowserTrix Cloud locally. The local deployment on Ubuntu, following the documentation on the BrowserTrix Cloud docs site, using microcates for the Kubernetes component, which all of their deployments now are with Kubernetes. It just worked following the documentation. We were able to get up an instance running and start crawling with BrowserTrix Cloud. But at UNT for production, we're going to need to use Red Hat most likely, just because that's what UNT uses. So I set about trying to deploy on Red Hat as well. Initially, I was using a Red Hat 7 virtual machine, and it didn't have the locale that microcates wanted. And trying to change things to get it to work was getting messy. So I switched to using a Red Hat 9 VM to avoid that issue. Another thing we needed to do was configure the firewall that was running, Firewall D on Red Hat, to allow communication between the pods. We also had to look at SE Linux and if it was blocking anything regarding microcates or BrowserTrix Cloud. I did see some things logged that looked like they were problematic and made some adjustments because we do run SE Linux enabled. Another thing that I hit was that I lacked enough storage where microcates wanted it for all of its parts, and then also for the crawler where it's writing works. I added more storage and adjusted the crawler request storage setting that BrowserTrix Cloud has to deal with this issue. Once I got BrowserTrix Cloud running, I found that some of the features weren't working for me. The browser profile, where you can get a browser in your page and log into sites like Twitter or whatever, and then use those browser profiles for crawling to log into those sites. It wasn't working. And also watching the crawl while it was running wasn't working when I was running it in Red Hat with microcates. And that's one of the neatest features about BrowserTrix Cloud. So I abandoned microcates with Red Hat and switched to K3s, which is also documented on the BrowserTrix Cloud documentation. And then all of the features seem to be working. And I'll just say that it does help if you have some knowledge of troubleshooting Kubernetes, if you hit any of these issues. Otherwise, it can be quite confusing. And the documentation for BrowserTrix does give you a little bit of hints on how to do some troubleshooting, so that's nice. Since I did go over all those bumps, I just want to show you that ultimately the commands to get BrowserTrix Cloud running with K3s on Red Hat aren't horrible. It's pretty short. You get the K3's install script and the Helm package manager script, and install those, set your firewall rules, and then you can pretty much run BrowserTrix Cloud with Helm, which will pull down the latest version of BrowserTrix Cloud and install it. Once you've got it up and running and you're ready to configure a crawl, BrowserTrix Cloud uses something called workflows. They have two types right now. URL list, where you can scope by just putting in a list of URLs. It doesn't recursively crawl any of them. It just gets that page, and then you can optionally get any linked pages as well. There's a seeded crawl scope interface as well, and there you put in a URL, say if you want it to be the domain and subdomains or the path, or additional scoping for that start URL. Again, you can do linked pages. You can also exclude URLs by patterns, and you can adjust this as the crawl is running, which is a nice feature. And you can also add a list of URLs there where it doesn't recursively crawl, but we'll get just those documents. After you set up the scope, the workflow for the URL list or seeded crawl is the same. where you can set the number of pages, how long to keep the crawler on a page, how long you want the crawl to last, the number of crawlers you want to run, if you want to use browser profiles for logging into sites, if you want to set the browser language to something other than English, if you want to try to block ads, and then when you want to crawl, and a name and a tag or tags for your crawl. So back to our use case at UNT, I was wanting to crawl pages with a lot of embedded videos per page. I had a cyber cemetery website that came up for the select committee to investigate the January 6th attack on the United States Capitol. And I crawled most of the site with Heritrix, but there were 15 pages with embedded videos, about 120 videos across these 15 pages that I wanted to get with Browsertrix Cloud. Most of these pages had a video that was about 2 to 3 hours long, and then 20 plus shorter videos. My initial results for trying to crawl this with Browsertrix Cloud using the default settings in the 4 browsers for one crawler instance that was default at the time, it was very bad and confusing. I only got 8 of the 120 or so videos. The interface reported crawling 15 of the pages, but only 6 of them actually appeared in the replay search results. I reduced the number of browsers to 1 to have better bandwidth, and ended up getting 50% of the videos, which was a big improvement, but not great. After adjusting settings, though, in the area of CPU, memory, and the crawler's behavior timeout and timeout, thanks to Ilya at Web Recorder for helping with this, I had only one of those videos that didn't work. So this was big for me, and I was very happy with this. And since I was testing these things, the default settings have been changed to better reflect local deployments and resources available. So I just, for completeness, I include here a slide with some of the suggested settings from Web Recorder for some of the crawler settings, and then you'll need to tweak the crawler request storage to what you have available and what you need. I list the behavior timeout and timeout settings I used, which were 3,000 and 300 respectively, and then you can adjust the number of browsers you use per crawler with the crawler browser instances setting. After that success with getting almost all of our embedded videos working, I did another crawl for embedded videos where I wanted to patch videos in a previous UNT crawl. We had crawled all of our unt.edu subdomains with Heritrix, and then as part of automated QA, using UK Web Archive's Web Render Puppeteer, I rendered the pages that we'd crawled with Heritrix in PyWB and wrote HAR files that included information about missing embeds. Then used some Python scripting to process these files and extract any YouTube video URLs that were missing, and then added them to a URL list to crawl in Browsertrix Cloud, which I crawled using 2 browsers. You can see here a screenshot of watching that crawl. The results for patching the videos with this UNT crawl were very good. I added the video works to PyWB with the existing UNT works, and the videos were appearing where they should and playing back in the page. And here is an example page where we had 4 embedded videos that didn't work before, but once we added the videos that we'd crawled with Browsertrix Cloud, they played back in our page in PyWB. I did a little bit of an extra test after finishing our video trialing with Browsertrix Cloud, and that was to crawl some Twitter. We generally don't focus on crawling social media at UNT at all, at least I don't. But to do this, I used Browsertrix Cloud's browser profile feature for logging into Twitter. Using the default settings initially with Browsertrix Cloud, it didn't scroll back very far, and I wasn't very impressed. But once we tweaked the settings and used only one browser and increased the crawler timeouts, it would scroll back about 6 to 7 weeks in this particular case, but only embedded videos and images were working for about 2 weeks. But still it's better quality than I was getting with Heritrix and PyWB, where I just end up with a something went wrong page, which a lot of you are probably familiar with. And it was a lot less tedious than manually archiving with PyWB record mode. So probably tweaking settings more, you could get better archive of Twitter. And if you're running these crawls regularly every few days or every week, it may serve your purpose very well. Once crawled, you can replay content in BrowserTrix Cloud overall. I like the replay interface features, but I find some of the things confusing. They use the term pages, where you can see in this top screenshot image that I did a crawl which reported 50 pages crawled, but in replay it says 2 pages found. That's because it only seems to count the URLs that you specifically put in. So if you're running a seeded crawl and you pick up other pages from that, they don't show up as pages. You can still search for them in the replay with all the other URLs. But even then, sometimes replay will falsely report pages as archived page not found, which is also confusing. And you can see here that happening. Web Recorder said this is a known issue happening because of the use of pre-signed URLs, I believe, with replay web page. But there's a purge cache and reload option in the interface to fix this. There are also inconsistent results when I was searching for URLs. There's a prefix and a contain search, and it seemed odd to me that searching with contains was giving me less results than with prefix. So just some oddities there. But ultimately, our users aren't going to be viewing the sites in BrowserTrix Cloud. So I downloaded the WACs that BrowserTrix Cloud was writing, unzipped them to access the works directly, used Linux rename command to adjust the file names to fit our normal convention, and combined the works with those from Heritrix and indexed them together for use in PyWB. And this all worked as expected. So with our use case wrapped up, our possible future use cases would be to use the software to archive student projects for theses and dissertations, where there's maybe a login required and an interactive site, including things such as, for example, a timeline like is pictured here. We've had this happen before, and the student had to use Web Recorder IO, now the Conifer service, to archive the site themselves. So hopefully we could take care of that with BrowserTrix Cloud next time. We might also use it as a teaching tool in the College of Information web archiving course that Mark Phillips teaches. If we have any university social media crawling we need to do, we could use BrowserTrix Cloud for that. And if we want any additional staff to manage crawling for specific purposes or are involved in any collaborative crawling projects with outside contributors, BrowserTrix Cloud would be an option to consider. Hopes for future improvements. I'd really like to see more documentation, particularly around production deployments, high availability to use multiple machines, and recommendations for settings. It would be nice if some of those replay experience inconsistencies were cleaned up. And then there are some issues in GitHub that I'm looking at for easier access to logs during and after the crawl, using something other than Let's Encrypt for managing SSL certificate for production deployments, being able to specify a work naming pattern so I don't need to rename files after the fact, monitoring crawling or monitoring disk space with crawling so that a crawler will stop when disk space is limited. That's something that Heritrix offers. And I did, encounter one time crawling much more than I expected and locking up, microcates and everything, and having to reset microcates and wipe out all of my data, which was okay because it was a testing environment, but I wouldn't want that to happen in production. And then to possibly be able to specify a storage path for local deployments would be nice. But even without those improvements, BrowserTrix Cloud is already improving the web archive experience for us. We're crawling pages with embedded videos that replay in PyWB. We're avoiding manual crawling, and it's easy to automatically deploy updates for BrowserTrix Cloud with Helm. So in summary, the story so far, the rapid software development work by Web Recorder and their attentiveness to user needs, I'm very impressed with. There does need to be more documentation though. But after configuring Browsertrix Cloud for our resources, it is serving our use case of embedded videos very well. So thank you, Web Recorder. Thank you, IIPC, and thank you for watching.